All right, this video is for lesson 3.6. We're going to do polynomial and rational inequalities. Okay. Somebody give me a number one.
The polynomial inequality x squared plus 8x plus 15 is greater than 0 can be solved by first solving the equation blank.
Solving the quadratic. So you would have to solve the quadratic
So we just do
first. That would be, the equation would be, you would set it equal to 0.
so x squared.
I believe that's what
it's not asking you to solve.
No, it's not asking you to solve.
And then the real solutions of this equation.
You may not have to put equal 0. Did you get that one right, baby, or have you not checked it yet?
I haven't checked it yet.
Oh, okay.
You have to set it equal to 0.
Okay, so the real solutions of this equation, -6 and -3, shown on the number line, are called, what are your other options?
Boundary and
I believe it's boundary.
That's what
Yeah.
Hey, so,
so you set it equal
that
to
was-
0?
it's not boundary?
No, it is.
Okay, well, all right.
You have to set it equal to 0 also.
Set this equal to 0. Shelby, what were your two solutions? What did it give you?
-5 and -3.
Okay, so -5 and -3, those two solutions, this is just for the video, are called boundary. Boundary points, is that what it says?
Yes.
Boundary points. So to show you, I don't know, did you do quadratics or quadratic inequalities in Algebra 2? Yes?
I believe so.
Okay. Just so you can kind of see what these look like. X squared plus 8x plus 15 is greater than 0.
Shades it.
Yeah.
That'll-
So, and if you want to look like, if you want to look at just the inequality, like there's just the, or just the quadratic, so you can kind of see where it's shading. Those are those boundary points that Shelby gave me, and it shades everything for this one to the left and the right of that. Just again, if you've never seen one of those shaded before.
I don't think we saw a quadratic, but we did do some
The linears, the straight lines.
linears, yes.
All of these are going to look a little bit different. So, all right, number 2, what do we got?
Polynomial inequality x squared plus 6x plus 5 is greater than 0. Oh wait, that's literally the same question. I'm such an idiot.
But is that number 2? Is that your number 2?
No, I was reading number 1.
Oh, okay.
The points at -7 and -1 shown on the number line below are the real solutions to the polynomial equation x squared plus 8x plus 7 equals 0, and represent the boundary points for the polynomial inequality x squared plus 8x plus 7 is greater than 0. The points at -7 and -1 divide the number line into which 3 intervals?
3 intervals?
Yes.
Okay. Multiple choice or fill in the blank?
Multiple choice.
Okay, so let's see if I can get this right without you giving me the multiple choice. Okay, so there's the quadratic, and then the inequality greater than 0. So it should be
Negative infinity
-infinity
to
to -7 bracket. Oh,
No,
Lord.
it was parentheses because it was less than.
Oh, because it's less than.
Yeah, I put it with brackets.
And then 7
-1
to -1,
and then -1 to infinity.
and then -1
So they're all parentheses.
to infinity. Yes, because of the sign. Thank you for bringing that up. If the sign is just less than, it's parentheses. If it's or greater than or equal to, that's when you use the brackets. Okay.
So, where are we? So on the graph,
Mhm.
what are we looking for on it?
So on the graph, see where mine is shaded here?
Yes.
It's gonna, the red goes all the way to -infinity, and then it's gonna stop at -7. The unshaded area is gonna go from -7 to -1. Those are the x-intercepts. of the quadratic. And then the other shaded area is from -1 to positive infinity. So you've kind of got those three intervals that you could be in terms of your x value.
So x could be in any three of those.
No, x could only be in the shaded. Because remember how linear inequalities work? Like, if we have like a straight line like this, and we shade down here, your solution has to be in the shaded spot. Same idea here. Your solution has to be in the shaded spot, in the shaded area, whatever your solution is.
Then why do we include the 2 to 7, or like on mine I have the points 2 and 7.
2 and 7. So why do you include those?
Yeah.
There is a way of thinking, and I've actually talked to some high school math teachers about this, that we should instead shade, so like what's not shaded, we should shade that area as an elimination. And so what that is that's the interval, that white interval on the screen, where the solutions don't work. Those are all the solutions that don't make the inequality true. So you have two areas of these are possible solutions, and you have one area of these could never be solutions, will never make the inequality mathematically true. But like I said, there's a way of thinking going around, and I actually agree with it. I like that better. Shading where it couldn't be as an elimination instead of shading where it could be. All right, number 3.
State whether the following statement is true or false.
Okay.
A test value for the rightmost interval on the number line shown below could be -8, and the points are -7 and -2.
Okay, so I'm just going to use Joseph's here to draw the example. So he's got a number line here, and he's got a dot at -5, and he's got a dot at -3. And it says a test value for the leftmost interval on the number line shown below could be -4. -4 is a test point. And so he put false, but it's true?
I haven't tested it.
Okay. Your test point should be,
Anything inside?
well, your leftmost test point should be -5. So again, think about how these are looking. Joseph was false, correct?
Yeah.
Okay. It should be that leftmost point. That should be your test point.
So if my number's not even in between the points, is that false?
Okay, so give me your 2 points.
-7 and -2.
-7, -2. What's your test point?
Rightmost interval on the number line should be, or could be -8.
Rightmost should be -8. No. False.
That would
Because your rightmost, this is going to be your rightmost test point. This one's going to be your leftmost test point.
I think with that last one, my question, I think it's because I was thinking like those are the solutions.
So yeah.
And now I realize it's not asking for those solutions. It's asking for the boundaries.
Well, and so that's what you're testing to overall what the solutions are for if you make it an equation. If you test anything that's to the left of this, a -10, it's not going to make this correct. But when we set it as an inequality, it would make it true. Because it doesn't have to be equal to 0 as long as this one is greater than 0. As long as this side is greater than 0. We can plug any x in there that makes this side greater than 0. But again, you're looking, those test points are where your boundaries are. Where it equals 0 exactly.
So your test points are always your roots.
Typically, yes. All right, number 4.
Solve the polynomial inequality and graph the solution set on a real number line.
Okay.
Express the solution set in interval notation.
Okay, so
I have.
we're gonna do a number line, and then you said interval,
Yes.
interval notation,
And
okay,
And we're graph, I guess.
and the graph. Okay,
What's the graph on the number line?
I have no clue.
okay. So what is yours,
Alright,
Peyton?
so it's our A factor. So in parentheses, x minus 3,
Okay,
close, then open, x plus 4 is greater than 0.
is greater than 0. Again, you've always got your test with Desmos. You can put factored form into Desmos. Why? I love Desmos. But again, you've got to know how to. Oh, if we could put right symbols in. Lord. Okay. So on a number line, you're going to have -3 and you're going to have 4. That's what it looks like on a number line. And it's going to look something like, does it have the bold, like, does it have this? Does it look like that on the number lines? Or
There's no
There is
actual
no number
number
line.
line.
You have to do the interval. So it's like a graph, like a table thing, and it says use the inequality in the form f of x is greater than 0. You have to put it like in a table.
interval. Use the inequality in the form to write the intervals as they appear from left to right on the number line. Oh. Yeah,
Let me view an example.
okay, view an example to see how they want that answer.
Oh, so you do like the
I don't know, I agree, I don't know what the bottom row is for. So like -infinity to -3, -3 to 4, 4 to positive infinity. Those would be the 3 blanks.
So what about your middle one? Would that be a negative or a positive sign? That's what I don't understand.
I don't understand what it's wanting there with the negative and the positive.
Okay, and it'd also be -4 and +3 on the graph. That's how
Wait. Her numbers are -3 and positive. Oh!
it's
Oh! Shelby, don't click that. Do you see? He caught what I did. It should be -4, +3, because this is x equals -4. This is x equals +3. Thank you for catching that. So they wanted negative, right?
that's how I put it, and it was still wrong.
It was wrong. So wait, was the way, Hunter, was the way that it showed you? Maybe the way they wanted it? Positive? Negative? Wasn't that the way that was?
The ones in
Mine was
ascending
negative,
order. I don't know.
Oh, this was supposed to be positive.
You answered negative and it should have been positive. So positive,
Positive,
positive.
Positive. How would the first one be positive?
That's what I was.
I'm not sure what they're talking about there.
Could it be like
Use the inequality
like
in the
positive would
form
be an answer,
to
-1?
write the intervals determined by the boundary points as they appear from left to right on the number line.
Okay, say that again, Shelby.
So all the instructions just say use the inequality in the form f of x is greater than 0 to write the intervals determined by the boundary points as they appear from left to right on the
Yes, so these are the 3 boundaries or the 3 areas, on there. The solution, though, would be, like on this one, -infinity to -4 union 3 to infinity. That's the area, those are the boundaries where the solution can be.
then the number line.
Does it have it like, is it multiple choice? Is it one sheet to put it
It's
in?
multiple choice.
Does it have the arrows like this?
Yes,
Yeah.
it hasn't gone out.
So, but make sure you have open circles.
It's parentheses
Yeah.
brackets on the
Oh, okay. So like
Open circles, just parentheses.
like this. I've never done that with the parentheses and the brackets and the number line, but that's interesting.
I mean, it makes it. It's pretty simple to. We decided on positive, negative, positive. We don't know why, but it is what it is.
All right, number 5.
It's asking for the solution set of.
Wait a minute. Could it be like if the arrows are going outwards, that would be positive, and then
Still doesn't make sense because technically, if you're going left,
yeah,
you're going
that's what
negative.
happened last time.
All right, Hunter, what was it, baby?
I just got it. It was the same thing as the last question, just without the first part, without the table. It's just asking for the solution set and then the number line.
Okay, so what's your
X or open parentheses, x minus 5, close, and open, x plus 4, close. This is greater than 0.
So yeah, it would be, so x equals 5, x equals negative 4.
So it's
So it would be,
infinity, negative 4, union 5 to infinity.
yeah, negative infinity, negative 4, union, 5, infinity. And then,
Question 6 is the same as 5. So
It's a less than or
it's
equal to something.
all right, so Shelby, give me your number 6.
Parentheses x minus 2, parentheses x plus 5, parentheses is less than or equal to 0.
Less than or equal to 0. Okay, so that's going to change it a little bit.
That's brackets, right?
Well, it's brackets, but x minus 2, x plus 5.
that'd be the middle. Is the solution.
Yeah. Okay, so it changes it when that sign flips.
So would it be the
So x equals 2, x equals negative 5. So negative 5, 2, it would be here,
oh, okay.
and then it would be negative 5 comma 2. So watch those signs.
So what is it? So it's just that's how you don't have a union. in it?
No, because it's just that one area that's the solution. When that sign flips, it's the middle section that becomes the solution. Okay. Getting there. 7.
You got it.
Same thing, except it's not factored.
Okay.
X squared plus 10x plus 21 is greater than or equal to 0.
Okay. So we can factor it though.
Yeah.
7 and 3. So again, always just kind of check if you need that check to see where greater than or equal to 0. Oop, 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 oop. There we go. Okay, you've always got that if you need it. So this one, x equals -7, x equals -3, -7, -3. This one is still brackets, but it's going
So that'd be
out, and it's a union. So this one would be -infinity. Now that one still gets a parenthesis. The 7 and the -3 are what gets the bracket. Infinity always gets parentheses. Ooh. Two more, right?
Yes, ma'am.
All right. Number 8.
3x squared plus 4x is less than 4.
Is less than 4, like that?
Yes.
Okay. Move all your pieces to one side. Okay? Because you want it to be 0. This one I would do slip and slide. So x squared plus 4x minus 12. 6 and 2. Slid the 3, so undo that. And so I would have x plus 2, and this one would be 3x minus 2, which would still be x equals -2, x equals 2/3. Again, I always check to see. I always check it this way too. So I always put the one they give me. Oh shoot, plus 4x is less than 4. And then after I change it, just to make sure that it matches. I don't know, I'm kind of weird with them that way. And so I got a -2 solution, and I've got a 2/3 solution, so my solutions are right. And then this one, again, if you look at the graph, it's just that center portion. So this one would be
-2 to 2/3.
-2 to 2/3, and it's going to be brackets. That was wrong?
Yes.
Crap. Do I have this right? Do I have the sign right?
Yeah.
It's not brackets. Front door.
Oh.
Good gravy. It's parentheses. -2 2/3.
Whoops.
Sorry.
Taking a second to load. It's
The internet's being weird, and what's weird about it is it's not just like our internet. Like at the house, I have internet through Taylor Electric, and it was real wonky all afternoon, all evening. And then I got up here, and the internet up here was real. So I don't know if we're on the same stuff. I don't think we are, but
Okay, Solomon, I think I did something wrong on mine.
okay. Let me look. All right, last one, number 9.
Same thing, but it's 5x is less than or equal to 12 minus 2x squared.
Like that.
Yes. Well, or equal to.
Oh, or equal to, less than or equal to?
Yes.
All right, so this one I'd move everything over here. The reason I'm moving everything this way,
Because you want the first one to be
I want the squared to be. So I've got 2x squared minus 12 plus 5x. So this one I would have x squared minus 12. Oh, gross. 2x squared plus 5x minus 12. Sorry. Okay. So x squared plus 5x minus 24. Twelve and 2 won't do it. 8 and 3.
Yeah.
8, 3, 8 has to be positive. So x equals negative 8. X equals 3. Okay. How you test a point. So we're looking at the graph to see where that area is. You can go off the signs. I pick a number in between. So like I'm going to pick a 2 here. I'm going to test x equals 2. And I'm going to plug a 2 into this. So 2 squared plus 5 times 2 minus 24 is greater than or equal to 0. So I've got 4 plus 10 minus 24 greater than or equal to 0. That's 14 minus 24. That's negative 10 is less than or equal to 0. So that means 2 is a point, which means it's the middle area. And that's why I picked the number in between. Because either the number in between is or it isn't. It's a guaranteed yay or nay on that one. So like I said, we've been checking where that interval is with the graph. That's how you do it by hand. So 5x 12 minus 2x squared, and then we changed it to 2x squared plus 5x minus 12, and then, so again, there it is on the graph. So like I said, I just pick a number in between those two solutions and test it. If it makes the inequality true, then it's the middle area. If it doesn't make the inequality true, then it's the outer areas. It's where we have that union.
That was incorrect.
That was incorrect? Okay. Not undo. Okay. So x plus 8, x minus 3, I moved to 2. So I've got x plus 4, x minus 3 over 2, which would be x equals a negative 4, and x equals 3 over 2. So that's what it should be, negative 4 and 3 over 2. Sorry. Which at least my test point is still good. Still in between. No, it's not. It's not. Crack. But it's showing it is. It's still showing that it's the middle. I don't know how I messed that one up. Oh, because I used this one instead of using this one. I just completely messed up that problem. Don't listen to me. I don't know what I'm talking about. It's still this way though.